Okay, in this session, what we're going to be doing is working on basically review for the Math 098 readiness test, all parts, section A, B, C, and D. Currently we're looking at section A, and section A deals primarily with solving equations. So starting with the first problem, what you notice, you have an equation that's looking to do distribution of a fraction into a set of parentheses. Now most students, as has been my experience, prefer not to deal with fractions if they can could possibly avoid it. So what I typically teach my students is to just go ahead and get rid of the fraction. Now we can do that by multiplying everything in the equation that's not in parentheses. Again, multiplying everything in the equation that is not in parentheses by a common denominator of the fractions. So if I'm looking at 1/3 as a fraction on the left hand side and 1/2 as a fraction on the right hand side, a common denominator would be 6, because I have 2 in the denominator here, 3 in the denominator there. 6 would be the first number that 3 and 2 would both divide into evenly. So if I multiply everything by 6 that's not in parentheses, which ultimately would be just a matter of multiplying the fractions by 6, I would get 6 times 1, which is 6, divided by 3, which is 2. So I'd have 2 times this parentheses right here, equals 6 times 1, again 6, divided by 2, which would be 3. So I'd have 3 times this parenthesis here. So now my problem would look like 2 6x minus 3 equals 3 8x minus 4. Now fractions are gone, so I'm just left with trying to simplify this further, and in this case distribution. Okay, so the 2 times the 6x, 2 times the negative 3, 3 times the 8x, 3 times the negative 4. So that leaves me with 12x minus 6 equals 24x minus 12. Okay, so now at this point what we're looking at is variable x on both sides of the equation. We have the equation, the equal sign here, so the equal sign splits the equation up into a left side and a right side. With variables being on both sides, I typically prefer to move the smaller variable, in this case the 12x, over to the bigger variable, which is 24x. So I move by subtracting 12x on both sides. Alright, cancels here. So that leaves me with this negative 6, so I'll write it up here. Negative 6 equals 24 minus 12 is 12. So 12x. And I still have this negative 12 that I didn't do anything with, so it's still there. Okay, so now I've finally been able to pin the variable down to one side of the equation. In this case it's on the right hand side, so that means I want to get the variable on the right hand side by itself. Alright, so in other words, I want this x on the right hand side by itself, so this 12 and this minus 12 here both have to move. So I'll move this minus 12 first because it's detached from the variable, so I'll add 12 to get rid of a minus 12. We cancel. Negative 6 plus 12 is a 6, equal sign. Alright, bring down my 12x. Now all I got to do is get rid of this 12 here. This is multiplication, so to undo multiplication, the inverse, which is opposite of multiplication, is division. So I divide both sides by this 12 that I'm trying to get rid of. And so now the 12s cancel over here. X equals 6 over 12, which is nothing more than saying x equals 1/2. Has to be 1/2, not 6 over 12. Has to be 1/2 because we always reduce, even if you're not asked to. Moving on to the next problem, number 2, we see a similar situation. We see fractions looking to be distributed into a set of parentheses. So we get rid of the fractions again by multiplying by a common denominator, which would be 12 in this case. Okay, so multiply both sides, both fractions, by 12. Again, we will multiply everything that's not in parentheses. This is in parentheses, that's why we didn't multiply it by 12. This information, this x minus 4, is in parentheses, that's why we didn't multiply it by 12. Alright, so 12 times 1 is 12, divided by 4 gives us a 3. 12 times 1 is 12, divided by the 3 gives us a 4. So now this problem looks like this. Okay, so the fractions are now gone, so we can distribute at this time. 3 times this, 3 times that, 4 times x, 4 times the negative 4, so that gives me 3x minus 3 equals 4x minus 16. Okay, once again, both sides of the problem contain a variable, so I like to move the smaller variable over to the larger. Since this is a positive 3x, I subtract 3x to move it. Cancels on the side that I moved it from. When I combine it on the right hand side, it becomes just an x. So I keep my negative 3. I didn't do anything to it, so I keep it. So negative 3 equals negative 3 equal sign. Now 4 minus 3 is 1x, so there's my 1x. And the minus 16 I keep because I didn't do anything to it. So there's my minus 16. Now to get x by itself, add 16 to both sides, and I end up with negative 3 plus 16, which is 13. Okay, so x equals 13. There's your answer. 13 equals x, or x equals 13. So there's your answer for problem number 2. Alright, so let's erase this. Take a minute. Scroll down. Alright, so now we're going to look at problem number 3. Okay, so in problem number 3, we notice once again we have variables on both sides. Here's an equal sign. Variables on both sides, so I move the smaller, which in this case would be the 8x, over here to the larger. So I do that by subtracting 8x from both sides. Alright, so that allows it to cancel on this side. That leaves me with a 10x. When I say 18 minus 8 is 10x plus 9, because I didn't do anything with it, equals what was left over here, which is a negative 1. Okay, got to get this by itself, so I move this plus 9 and this 10. Move the plus 9 first because it's separated from the x. If you notice, the x has a plus or minus sign in between it and the number. So that's what I mean by separated or detached from the variable. So I'll move anything detached before I move anything that would be considered attached to the variable. In this case, the 10 would be considered attached to the x. So we're going to move this 9 by subtracting from both sides. Cancels. So 10x is left on the left hand side. 10x, that's gone. Equals negative 1 minus 9. Negative 10. Divide both sides by 10. X equals negative 1. There's your answer. And that was number 3. Problem number 4. We notice we have this minus sign next to this set of parentheses. And anytime you see that a minus sign next to a set of parentheses like this, that would be considered distribution of a negative 1. So basically what you have to do is imagine that there's a 1 right here. So this would be like saying negative 1 times 5x, negative 1 times a negative 1. So you're distributing that negative by everything in parentheses. And at the end of the day, all it really amounts to is changing the signs of everything that's in the parentheses. So now this problem will look like this. 6x stays the same. Now this negative 1 times 5x makes it a negative 5x. Alright, and this negative 1 times this negative 1 becomes a positive 1. And you still have equals 2 on the other side. Didn't do anything there. Now, if you notice, we have like terms on the same side of the problem. These two terms, the 6x and the negative 5x, are like terms, and they're both on the left-hand side of the equal sign. So they're on the same side. They're all on the left-hand side of the equal sign. So we now will combine these like terms, and that would 6x minus 5x would give us 1x. You still have plus 1. So plus 1 equal to 2. Now, get x by itself, you got to get rid of plus 1. It's detached. So we subtract 1. Subtract 1 from the other side. Okay. That cancels. So now you have x equals 1. 2 minus 1 would be 1. These cancel. So there you go. That would be number 4. Okay. Number 5, decimal problem. Split the problem up. Again, variables on both sides. You have a negative 6.3x on this side, a negative 1.66 on this side. As I've said in the previous problems, when you have variables on both sides of the equal sign, both sides of the equation, move the smaller to the bigger. Now, because both of these variables are negative, when you're thinking of the smaller, remember, negative is opposite of positive. So if I was looking at this as a positive 6.3x and this as a positive 1.6, I know 6.3 is bigger than 1.6. But because I'm looking at them in the negative version, just the opposite is true. So instead of 6.3 being bigger, a negative 6.3 is smaller than a negative 1.6. So this would be the one that I move. So I move a negative 6.3 by adding 6 plus 3. 6.3, excuse me. Okay. Cancels there. And on the other side, I end up with a 4.7. So on the left hand side I have nothing over here, so I can't just leave it blank. I have to put something, so I just write 0. Okay, I write 0 for this side. Still have my negative 32.9, and when I say my negative 1.6 plus 6.3, I end up with a positive, so plus 4.7x. Alright, so I'm trying to get that by itself, so I move this negative 32.9 over to the other side by adding. So I add 32.9 to both sides. Cancels on this side. So now I'm looking at 32.9 equals 4.7x. Divide both sides by the 4.7. Okay, so I have 32.9 divided by 4.7. That gives me 7. So I'm left with x equals 7. Alright, so that would be the answer to problem number 5. Let's erase some of this, clear some space. Okay. Scroll down right quick. Alright. So let's go here. Alright, so now we're going to be ready to move on to problem number 6. Problem number 6, once again, is a decimal problem, variable on both sides. Variable on both sides. As before, moving the smaller to the bigger. because negative is opposite of positive, this 8.6 negative is actually smaller than negative 1.2. So we're going to move the negative 8.6 by adding 8.6x. Add 8.6x to both sides. Okay. Plus. And so when I do that, cancels on this side, left with the 1.1 equal sign, still have my negative 58.1. Alright, so now I say a negative 1.2x plus 8.6x, and that gives me a positive 7.4x. So now to get x by itself, I move the detach first, which in this case is the negative 58.1. So add 58.1 to both sides. Cancels here. So now I have, what is that, 59.2 equals 7.4x. So the 1.1 plus the 58.1 gives me 59.2, and the 7.4x is brought down. Okay, divide both sides by 7.4. Uh-oh, let me go back. Looks like I lost some material there. Okay. I guess I did lose it. Alright, back to this problem again. So I had to pause. The student came in. Sorry about that. Variable on both sides, moving the smaller to the bigger, so I'm going to add 8.6x to both sides. Add 8.6x to both sides. Cancels here. 1.1 equals negative 58.1. Okay, so that equals a negative 58. 1.1 equals a negative 58.1, and my negative 1.2 plus 8.6 gives me a positive 7.4x. Now I add 58.1 to both sides. Cancels over here. 1.1 plus 58.1 gives me 59.2 equals 7.4x. 7.4, I didn't do anything with it, so I just kept it. 1.1 plus 58.1 gives me the 59.2. Alright, so now at this time I would divide both sides by the 7.4. So 59.2 divided by 7.4 would equal 8. So x equals 8. Alright, answer to number 6. Number 7, simplifying by combining like terms on the same side. So go ahead and combine those. 5x plus 4x is a 9x. So when you simplify, you end up with 5x minus 4, which is what you see over here on the left side, equals 2 plus 9x. Okay. Variable still on both sides of the equation, moving the smaller to the bigger. So minus 5x minus 5x. So that cancels. For 9x minus 5x, 4x. So negative 4 equals 2 plus 4x. Subtract 2. Subtract 2. Cancels. Negative 4 minus 2 gives me a negative 6 equals. Alright, so the negative 6 comes from here. gives me the negative 6 equals, and I keep the 4x. Alright, divide both sides by 4. Alright, so 4 is canceled. X equals negative 6 over 4, which is the same as saying x equals negative 3 over 2, because 2 goes into 4 2 times, 2 goes into 6 3 times. Again, you always have to reduce. So there's that answer. Okay, and then number 8 is a fraction problem like problems 1 and 2 that we saw. Fractions, but this time we don't have any parentheses. So that when we find the common denominator in this problem, we multiply that common denominator, like I said before, by everything that's not in parentheses. So in this case we have a 2, a 3, and a 2 in the denominator, so the common denominator would be a 6. So multiplying everything by 6 that's not in parentheses. Alright, so 6 times 1 is 6, divided by 2 is 3. So that's a 3x. 6 times 2 is 12, so plus 12 equals 6 times 1 is 6, divided by 3 is 2x, minus 6 times 1 is 6, divided by 2, which is 3. So now we've gotten rid of all of the fractions, and we're left with a problem that looks a little bit easier to deal with. Variable is still on both sides. Move the smaller over here to the bigger, so I'm going to subtract 2x from both sides. So if I subtract 2x from both sides, it's going to cancel on this side, and 3x minus 2x is going to give me 1x. Still have my 12 equals a negative 3. Again, I subtracted 2x, so minus 2x minus 2x. They cancel, so it just left the negative 3 on the right hand side. 3 minus 2 gave me the 1x, plus 12 plus 12. There it is. So now subtract 12, cancels, x equals negative 3 minus 12 is a negative 15. Okay, so there's your answer for problem 6, 7, and 8. So now let's look, I guess, here at problem number 9 and write some of the stuff first. Alright, looking at problem number 9, they're wanting us to manipulate this equation so that it's solved for S2. Currently the equation is solved for P. Alright, P is what's isolated, what's alone in the positive version. So this equation is solved for P. But what they really want is us to turn around and solve this equation for S2. So if I rewrite the equation, P equals S1 plus S2 plus S3, and I want to solve for S2. Alright, then that means I want S2 on the right hand side of the equation by itself. So if I want to get this S2 by itself, then that means I got to get rid of this S1, and I have to get rid of this S3. Now because S1 and S3 are detached from S2, because there's a variable, not a variable, because there's a sign in between what we want and what we're trying to move, then we use addition or subtraction. Now this S1 is positive, so I subtract S1 to move it. If I do it on one side, I have to do it on the other side. So S1 cancels. P minus S1, these are not like terms, so we write it out. P minus S1 equals S2 plus S3. Still want S2, so we got to get rid of the S3. So subtract S3 on both sides. So minus S3. S3's cancel over here. None of these are like terms, so once again we just write it out. So P minus S1 minus S3 equals what's left, which would be S2. So that would be your final answer for that one, number 9. Number 10, currently this equation is solved for V, and they want you to turn around and solve it for b instead. So we're trying to get b by itself. So that means we have to get rid of the 1/3 and the h. Okay, so to get rid of the 1/3, we multiply both sides by the reciprocal of this fraction, the flip of this fraction, which would be 3/1. So multiply both sides by 3/1, which is just 3. So I multiply the left side by 3, and I multiply the right side by 3. Alright, so there's my 3 that I multiply both sides by. Okay, so now on the right side, the 3's cancel. On the left side, I just end up with 3v. 3v equals 1 times anything is just that thing, and again, this is an h, this is not a b, so this is b h. Okay, so 3v, 3 times v is 3v. 3's canceled over here when I multiply this by 3, leaving the bh. That's supposed to be an h. Alright, so now if I'm just still trying to get b by itself, I get rid of the h. B next to h, bh is multiplication, so to undo multiplication we divide. And we divide both sides by what we're trying to get rid of, which in this case is h. H is cancelled, 3v over h is left, and now b is by itself. So that would be your answer. So for problem number 9, your answer would have been S2 equals P minus S1 minus S3, okay, which was C. And let's see here. For number, what is it? Let's see. And for number 10, what we ended up with was B equals we ended up with, for number 9, C being our answer, and for number 10 we ended up with B equaling 3V over H, which B should be our answer choice. Alright, so that's our answers for those two, for 9 and 10. For number 11, 94 is 60% of what number? Now, number 11 and 12 are ratio problems. So when you think ratio, what you're really doing is over of equals some percent over 100%. Okay, is over of equals some percent over 100%. Now they say 94 is, so since 94 is, 94 would go right here. Is 60%. 60% would be this percent right here. Alright, so we set this up by saying 94 is 60% of what number? Of is on bottom. Of what number means we don't know the number, so we represent that by X, and we know this is 100. Alright, you always will have 100 at the bottom on the percent side. So then you just set this up by cross multiplication. So you have 9400 equals 60x. Divide both sides by 60. And so you have 9400 divided by 60 equals 156.67. 156.67. This here which would be A. Okay. Number 9, round the answer to the nearest tenth of a percent. Okay, rounding. Alright. And the reason why we said this was 156.67 is going back to 11 right quick, rounding to the nearest hundred. That's important. What we got was 156.666, and they kept going. They want to round to the hundred. This 6 right here would be in what we consider the hundreds place. So if we want to see if we're going to round this 6 up or keep it the same, we have to check the number just to the right of it. Now, if that number to the right is between 0 and 4, then this 6 here in the hundreds place will stay the same. But because this number that we circled to the right is greater than 4, so it's a 5 to a 9, then that makes this 6 round up to a 7. Okay, so that's why if you notice over here we have 0.67, because this 6 that circle makes this 6 round up to a 7 in the hundreds place. Alright, so we're looking to do the same thing here for number 12. Is over of still equals some percent over 100%. So they give us 410 is, so 410 is what percent? So now we don't know the percent, so we put the X there, and it's always over 100. And then of 1970, of 1970. There's your setup. You'd cross multiply, and when you did that, you'd have 1970x equal to 410. Excuse me, erase that. Zero, so 41,000. Okay. Then you would divide 1970 on both sides. Cancels. And you'd be left with X equaling 20.812, keep on going, but they want to the nearest tenth. Okay, so the tenth is represented by this 8, first place after the decimal, to the right, first place to the right of the decimal. So 8 would be in the tenth place, so I'll look at this 1, and again this 1 right here tells me what to do with this 8. Now because 1 is less than 5, that means this 8 will stay the same. If 1 was 5 or greater, then this 8 would round up to a 9. So our answer becomes 20.8. So D would be the proper answer choice. Alright, moving on. Okay, 13 and 14. Excuse me. For number 13, they want the sum of 3 consecutive integers, and they're saying they're equal to a negative 420. Find all 3 integers. Alright, so what we need to know is for consecutive integers, that means the numbers are, say, back to back to back. So 1, 2, 3, 5, 6, 7, 22, 23, 24. Alright, so 3 numbers that are back to back to back, 3 integers. Okay, and when we're talking about integers, again, we're talking about all whole numbers, 0 to infinity as well as 0 to negative infinity. Alright, so in this case we don't know what the integers are, but we know the sum of them, the sum, which means add. The 3 numbers add up to equal a negative 420. Now if I don't know what the first number is, I just make it an X. Now let's just, for the sake of argument, say the 3 numbers were 3, 4, and 5. So let's say those were the 3 consecutive integers. Alright, so now if 3 is my first number, how do I get from 3 to 4? How do I get from 3 to the next number in line? Well, all I have to do is say my 3, my first number, plus 1 will give me that next number in line. So 3 plus 1 gives me that 4. Alright, so now I see that 5 is the second number in, or the third number in the sequence. So again, I'm trying to get from my first number to this 5 now. So how would I get from 3 to 5? Well, I get from 3 to 5 by adding 2. So 3 plus 2 is 5. So 3 being the first number, to get the next number, I just add 1 to the 3. That gives me 4. To get the third number, I add 2 to the 3, and that gives me the 5. So that's how I would get 3 numbers consecutively. So now, going back to our problem, if x is the first number, to get the second number, I say x plus 1. This is my first number, x. So my first number plus 1 would give me my second number. Just like we said, 3 was our first number, and our first number plus 1 gave us our second number. So our first number is x, x plus 1 is our second number. So to get our third number, we say our first number plus 2. Okay? So x is our first number. Okay? So x is our first number. X plus 1 is our second number. So first number is x. Second number is x plus 1. Third number, x plus 2. Let's sloppy. Hold on. Okay, so now first number, second number, third number, and we said that the sum of these, so add these all up to get negative 420. So if I added these all up, so if this plus this one plus this one, it should all equal negative 420. Okay, so now what we notice is we have like terms, so all the x's are like terms. So if you notice, there's an x, here's an x, here's an x, so that gives you 3 x's. This 1 and this 2 gives you a positive 3. So at the end of the day, all of this really simplifies down to 3x plus 3, and it's still going to equal negative 420. Okay, so now you have an equation you can work with. 3x plus 3 equals negative 420. Subtract 3, subtract 3, that cancels. 3x equals negative 423. Divide both sides by 3. Okay, so negative 423 divided by 3, and you end up with x equals negative 141. Alright, so if x is negative 141, then you know this is your first number. So negative 141 is your first number. So your second number would have to be negative 141 plus 1. Alright, because it's x plus 1 for your second number. So if x is negative 141, negative 141 plus 1 would give you, your second number would be negative 140. Okay, because negative 141 plus 1 is negative 140. And your third number, which is x plus 2, would be negative 141 plus 2. So negative 141 plus 2 gives you negative 139. Okay, so second number, third number, and if you notice, you take negative 141, negative 140, negative 139, and combine them, you should end up with what we were looking for, which was negative 420. Alright, so your answer to this problem should be first number, second number, and third number. You have to list all three of these numbers. Okay, and now the last problem. A rectangle has a perimeter of 114 inches. The length of the carpet is 3 inches more than the width. What are the dimensions of the carpet? Okay, talk about a rectangle. Alright, so perimeter of 114 inches. So that means we're going to add all the sides up to equal 114 inches. That's what it means by perimeter. Add up all the sides to equal 114. Now it says the length of the carpet, so perimeter was the key. Perimeter is the key. Fact there's a rectangle is the key. Alright, 114. Length of the carpet is 3 more than the width. That's critical as well. Okay, so we want to know the dimensions. Now the length is 3 more than the width, but we don't know what the width is, so we just say, because we don't know the width, we just say W. W will be our width. Alright, so W will equal our width. We don't know it. Now the fact that we're dealing with a rectangle lets us know that opposite sides are going to be the same. So if this is my width, then because of the rectangle, the opposite side is going to be the same thing. So if width is W, then this other side will be a W. Now, as far as the length of the rectangle goes, how long it is, the problem says the length is means equal sign. So length is 3 more than the width. The length is 3 more than the width. So you have this equation to use to find your length. Or length is represented by the expression 3 plus W. Okay, so now we write 3 plus W, and because of the rectangle, if that's true on that side, then it'd be the same on the other side. Alright, now the perimeter is 114, so perimeter means I have to add all of these up. So add up a W plus another W plus a 3 plus W plus another 3 plus W equals 114. Alright, so then when I look, like terms, there's a W, there's a W, there's a W, there's a W. So that's 4 W's. And when I'm looking at just constant terms, that 3 plus that 3 gives me 6 equals 114. Come over here where we got some room. Subtract 6 from both sides. See, I'll do it up here. 4W plus 6 equals 114 minus 6 on both sides. Cancels. 4W equals, what is that? 114 minus 6 is 108. Okay. So now divide both sides by 4, and you have W equals 108 divided by 4 equals 27. So your width is 27. Now, width is 27. So there's one of the dimensions, the width. The other dimension we said is length. Well, we said length is 3 more than the width. Length is 3 more than the width, and we said the width is 27. So 3 more than 27, length has to be 30. So the width is 27, the length is 30, and we check it out. So if you have a rectangle, okay, let me erase some stuff for us. Oh, here, I'll just write it up here. That's okay. We have our rectangle. Said our width is 27. That's going to be 27. 30 here. 30 here. If I add up the 30s, I get 60. And then add up 27s. Excuse me. 27s. And that gives me 4. 7, 7, 14, carry the 1. So that's 4 and 3, 7, 7, 2, 9, 9, 2, 11. So there it is. If you add all these up, you get 114. So that tells us that our length must be 30 and our width must be 27. Alright, so that concludes our review of Part A of our Math 098 readiness test. I will follow with Part B shortly.